So far, we have learned how we can calculate duration and the features of duration. Now we are ready to make the direct link between duration measured in years and the interest rate sensitivity of an asset or liability or of a financial institution's entire portfolio. In addition to being a measure of average life of cash flows of an asset and liability, duration is also a direct measure of the interest rate sensitivity or elasticity of an asset or liability. In other words, the larger the numerical value of D that is calculated for an asset and liability, I mean duration, the more sensitive the price of the asset or liability to change in interest rates. So if you look at this equation, this left-hand side, that's actually the change in price, change in market values. So change in price divided by the baseline price. Now that's essentially is a duration. So that was I was saying just a few moments back that the numeric value of this duration indicates that how sensitive this price change to a given change in interest rate. Okay, so this part is the change in interest rate, this part is duration. That makes how much the price will change. Okay, so we already know how do we calculate D. Now, as this D is multiplied by, D is divided by 1 plus R, I mean this part, this denominator, then it's called modified duration. So this modified duration is multiplied by the change in interest rate. That means as we multiply change in interest rate with the modified duration, we get how much the price will change. Okay, so the number D is the interest elasticity or sensitivity of the securities price to small change in interest rate. Okay, that is, it describes the percentage price fall of a bond for any increase in the required interest rate. It means that if an interest rate increases by, for example, 1%, this D will tell you how much the price will decline. Okay. So you can see in this equation that for a small change in interest rate, bond price will move in an inversely proportional fashion according to the size of the D. You can see the D is negative, so price will change in an inversely proportional. Clearly, for any given rise in interest rates, long duration securities suffer a large capital loss. On the other hand, for a fall, the long duration will receive a higher capital gain than do the short duration securities. Okay, so we find that the gains and losses under the duration model are symmetrical. Symmetrical means that as the interest rate changes, the price will change symmetrically. So for a given rise in interest rate, the price will fall to a certain extent. For a given fall in the interest rate of the same degree, the price will increase by the same degree. Okay, so if we look at this graph here, you can see that here is the price change and here is the yield change. So as the yield changes, the slope of this line is the duration. So as the yield changes, price will change inversely proportionally by the amount or by the proportion of D. Now look at this example here. Consider a bond that we have seen in exercise 1. The present value of the bond was 25,770. Its duration was 1.95 years and interest rate was 8%. Right? Now, what happens to the price of the bond if interest rates increases by 1%, interest rate decreases by 1%? Okay, so you can remember this equation. Change in price should be D, which is the duration, multiplied by change in interest rate divided by 1 plus R. So our duration is 1.95 and interest rate change is 1%, then 1 divided by interest rate. You can say it's negative 1.81%. It means that as interest rate increase by 1%, the price will decrease by 1.81%. Similarly, As interest decrease by 1%, price will rise by 1.81%. The point I was discussing few moments back, for a given change in interest rate, the price change is symmetric. You can see that when interest rate increases by 1%, price decrease by 1.81%, and when interest rate decrease by 1%, the price increase to the same percentage. So that's the symmetric impact of interest rate change on the price change of the bond. So this part is also called modified duration. Modified duration, as I was saying here, this part, I mean, when duration is divided by 1 plus r, which is also known as modified duration, and as a modified duration is multiplied by the interest rate change, that's the price change. Okay, now this price change, this actually will indicate that how much the price will change for a given change in interest rate. Now, we also can use the dollar duration term to calculate the dollar change in price. For example, if we have a dollar duration, which is modified duration multiplied by price, that will indicate how much the price will change in terms of dollar rather than how much the price will change in terms of percentage. Okay, let me give you an example very quickly. Let's say that modified duration of a security is 4.623. Now, if the price of a bond is 1,000, so 4.623, that's the modified duration for the bond. And if price is 1,000, for example, now as we multiply by this price 1,000 by 4.623, we will get 4,623. It means that as the interest rate changes by 1%, I mean 100 basis point, the bond price will change by $46.23. Okay. So that's a use of dollar duration term. So the bottom line is, as we multiply by this modified duration by the interest rate changes, we get the percentage change in the price of a bond. And if we get a dollar duration and multiplied by the price, we get how much the price of the bond will change in terms of dollar. So that's the end of our discussion with regard to the economic meaning of duration. In the next video, we will discuss how this duration concept can be used in terms of the entire portfolio of a financial institution. Thank you very much.